So in today's video, we're going to convert our graphs that we have been working with yesterday into equations. So the focus is still very high on understanding what is in front of you and how equations and graphs are related. So as before, so our focus yesterday, we really were focused on these two numbers. What is the value of slope and what is the value of y-intercept? So the first thing, so the same two things as I said, like B, y-intercept, y-axis crossed at what value? Not coordinate point, but specifically what is the value of y at that point. And then we have our slope, aka ratio. We need to have it as a ratio of rise over run, or as you remember, if it's a negative, we would say fall over run. All right, so example number one. Let me zoom in on this. And so what we have here is, I know that they do list slope first, but I really want to make sure that you're starting with y-intercept. It's just going to make things a little bit easier because it does start, it does give you the beginning point. So we begin with B. So the B value is right here, equaling 3. Again, not a coordinate point, but value of where the y-axis has been crossed at 3. All right, so then we determine our slope. Rise and run. Okay, how do we determine where we're rising and running? We need to pick a perfect point. I have mentioned this earlier when we talked about analyzing the slope. So earlier video this week. So this is my next perfect point. So my y-intercept is perfect point. I know exactly precise location. It's really nice, easy to read. Again, what makes it a perfect point is the fact that you can very clearly identify its location. So again, if I were to write the coordinates of this point, they would be 2 and 6. Okay, not 2.5, not 2.3, not 6.8. Very, very nice numbers. You should not pick the value that sits right here. Look, it's not on intersection of x and y axis or the grid or anything that's very perfectly defined. All right, so from here, I am ready to compose my rise and run. Okay, so if I were to create this little triangle, these triangles are really, really handy. 1, 2, 3, 1, 2. My rise is 3, my run is 2. I'm ready to put my equation together. So I was missing slope, or this y-intercept, and slope. So 3 over 2 plus 3. Here's my equation. All right, let's do this for example number 2. We're going to begin with B. Where did our graph cross our y-axis? Right here. So if this is my origin, 1, 2, 3, 4. My y-intercept is 4. I began with 4. Even though, yes, the graph starts somewhere here and it crosses down, you still want to have the same approach. Where's it beginning? Because from that point, you're going to determine your slope. All right. Again, looking very carefully, and so I don't have to look super long. Here's my perfect point right here. I'm going to zoom in so you can see what I have plotted. Here we go. So I have a negative slope. I will actually fall and run because I'm noticing a trend of decreasing behavior. My values are decreasing. So how many times am I falling? 1 and then 2. So I'm falling 1, running 2, and that gets me to another point. You always want to double check that your pattern or your observation can be confirmed and can be repeated maybe once or twice or even more. Fall 1, run 2. Fall 1, run 2. Fall 1, run 2. So negative 1/2. Y equals negative 1/2 x plus 4. It is a negative slope. I have a negative ratio. My line is falling. All the things I have in front of me to confirm that behavior. All right, let's flip on the other side and take another look. We'll take a look at more examples. These other examples that you are seeing, they are set up a little bit better for us because they're already providing us with some points to work with. So let's start with Y-intercept. We begin with B, and hopefully it looks very familiar. This is our origin, so we need to write it down. I do want for you to make sure you're writing down, breaking down this particular graph. So it is starting at a 0. It is going to be super important value in your equation. For our slope, what we're going to do is we're going to use the points that we have on this graph. Why not? Absolutely awesome, handy information right here. So I am observing that my graph is falling from left to right. So it's going to be a negative 5, falling 5 units, and running 5 units. Oh, well, negative 5 over 5 is the same as a 1. So what I'm going to do next, I'm going to just double check. Okay, if I fall 2 units, am I running 2 units? Yes. So this little pattern, look at this, my friends. I can do this several times. And all of these little similar triangles that I am drawing, they all reduce to the value of negative 1. When we talked about this yesterday, you always can reduce this. So all of those ratios would be the same. So I am going to write the equation in full format first. So we have negative 1x plus 0. That simplifies to super, I don't want to say simple, but we saw this yesterday. We saw this equation yesterday in our note, and this is how it happened. This is a great example. Make sure that you, if you are having a hard time with that, maybe you can get your attention to it, kind of like, wow, I went from a whole lot of numbers, whole lot of options to extremely simple equation. I want to make sure you know what it means. All right, example number 4. All right, we're going to begin with 7. Y-intercept equals 7. B equals 7. And I love when we have these little coordinate points for us. They're telling us exactly which points to use for our rise and run ratio. Once again, we have a negative slope. Our graph is falling from left to right. So from 7 to 4, it fell 3 units. 3 units. From 4 to 4 right here is 4 units. So then we have negative 3/4. Again, do not convert this equation into, or do not convert this ratio into a decimal. You would write it as it is, and plus 7. This way, when you need to double check and go back to the graphing, you can easily do so. All right, example number 5. I love this example because it shows that you are not always going to have nice numbers that just simply going by ones. All right, let's start at the beginning. The Y-intercept, begin with B. Where do we begin? We begin at the origin. B equals 0. Yes, B equals 0. So then when I am analyzing my pattern of my graph, I see that it goes so perfectly in a very, very nice pattern. So if I try to find my relationship between numbers, I'm seeing the pattern: 15 to 1, 30 to 2, 45 to 3. All of those are reduced to what value? So 15 to 1, 30 to 2, 45 to 3. All of these ratios, 15 to 1, 1. 30 to 2, 45 to 3, all well, you don't see what I wrote, my apologies, 45 to 3, all reduced to 15 over 1, or simply 15. Y equals 15x. So where did the y-intercept go? Hope you remember that when your y-intercept equals 0, we do not write it down. We write it in the simplest format possible. So that's just a designator. Oh, it goes through the origin. It goes through 0, 0. The value of y-intercept is 0. All right, example number 6. Another awesome example of seeing that your values are not going to be always going by ones. So let's take a look. We begin with b equaling 0. It's proportional graph. So this example is even better. Look what's happening. So I am going to travel from my y-intercept to 2 units and then over 1 to get to my value. Okay, so I needed these 2 points to determine my ratio of rise over run. My rise and run, please pay super close attention, are not 2 to 1. They're not 2 to 1. My rise and run ratio are 10 to 1. Okay, even though I am rising 2 units on my grid, the value of those 2 units is 10 points or $10 or whatever the discussion would be later on. Okay, so slope is 10 over 1, not 2 over 1. Uber important. 10x is your equation. So this is another one, and I did not get that much attention to the scale in example 5, but it's the same kind of concept. You went one value, 1 unit over 1 unit, but it was not a slope of 1. It was not a slope of 2. It was slope of 15. Okay, so these are a little bit more unique. And of course, number 7 and 8, you are seeing, wow, these are our 0 slope and horizontal an undefined slope. So we have vertical line and horizontal line. So how do we deal with these particular questions? So undefined slope versus 0. Okay. Not comparing them really side by side. Ooh, what happened here? All right. But I do want to talk about, just the basic breakdown. If I say, what is your y-intercept? You don't have any. Okay? So that part is absolutely missing in your equation. You do not have anything y. No y at all. Okay? No y at all. Slope, rise and run. So when you're trying to determine your rise and run, you can try to. We can do the math. So I picked 2 good points. So if I rise to, yes, I am rising 2, but then my run, am I running anywhere? No, I'm not running anywhere. This right here, this rule is not allowed in math. You cannot divide by 0. Okay, so that is the reason we call this undefined. Okay, you do have a numerical value because the graph does exist, okay, and exists based on only this relationship, x equals 3, and that's the only value that we can use. All right, in our last scenario, example 8, we do have a y-intercept right here, so it's 1, 2, 3, 4, 5, 6. Y-intercept is 6. our slope. We do have two handy points, so let's take